Hey guys, so today we are discussing earthquakes. We know the basic understanding that earthquakes are caused by plate motion. And to be more specific, almost all earthquakes occur at plate boundaries. So a couple weeks prior, we talked about convergent, divergent, and transform plate boundaries. So all of these types of plate boundaries have earthquakes, some more frequent than others, but we know that that happens due to the convection within the earth that causes those plates to move. So we know as those plates move, we have stresses that build, and when those stresses are too much, the rocks break. So it releases that energy that's stored in the rocks, and then that sudden release is an earthquake. So during an earthquake, the rock usually will move several centimeters, but sometimes it can move up to a few meters as well. So when we talk specifically about earthquakes, there are two main words that describe the earthquake's location, and that is focus and epicenter. So when we talk about the focus, that's the point where the rock actually ruptures, and that's the earthquake's focus. The focus is below the Earth's surface. So a shallow earthquake has a focus less than about 45 miles below the Earth's surface. And then an intermediate focus earthquake has a focus between 45 to 200 miles. And then if we go even further into the Earth's surface, a deep focus earthquake is basically anything greater than 200 miles. So about 75% of the earthquakes that have a focus at the top, like 6 to 9 miles of the crust. And then shallow earthquakes cause the most damage on the Earth's surface. So damage in regards to where people live. And so in particular, when we talk about the epicenter, that's going to be the area directly above the focus. So it's actually on the land's surface. And basically, the towns or cities near the epicenter will be strongly affected by the earthquake. And basically, these earthquakes, within like a single year, on average, there's about close to 900,000 earthquakes that are actually recorded. And that's recording using a seismogram, which records a seismograph that seismologists are able to study and analyze and report their findings that actually help us understand what happens within the earth. So about 150,000 of those 900,000 are strong enough to be felt. So that means that there are earthquakes that occur that we actually can't feel, but when we have magnitudes that, as they increase, that's the likelihood that you'll start to feel them. So about each year, there's around 18 earthquakes that are considered major on the Richter scale. So the Richter scale is how we measure the magnitude of earthquakes. And so a magnitude of around 7 to 7.9 is an average earthquake. And higher than that is going to be extreme. So a magnitude of 9 earthquakes are very, very rare. There's been about 5 since the United States Geological Survey started recording data since 1900. So 5 out of that time frame, so over 100 years ago. And basically all of them occurred in the Pacific Ocean. as well as the Indian Ocean. So none were actually felt within the continental crust. So if we talk more specifically about earthquake zones, 95% of all the earthquakes take place along those, like I said, those three plate boundaries. The Pacific Ocean Basin is the most prevalent area where earthquakes happen because of areas of convergent and transformed plate boundaries. The Himalaya region is the second most active due to the plate boundaries that converge between India and Asia. So you can see in these images just how prevalent earthquakes are, and they happen to be all throughout the world. So we have a United States image as well as a world image, and you can see in areas in the blue, that's going to be the Pacific plate, and that heavily blue area at the top left corner is going to be Alaska. And then if you go further down, that's going to be California into Mexico. So that's a huge plate boundary located there, but you can see scattered throughout the world that there's other active plate boundaries as well. So when we talk about seismic waves, we're talking about how the energy that is dispersed from the earthquake actually happening, how it travels. So seismic waves there are different types of seismic waves. We have body waves that travel through the body of the planet, and then surface waves that actually travel along the surface. And they can be narrowed down more specifically into P and S waves. With the two body waves, the P waves actually travel the fastest through solids, liquids, and gases, and then the surface waves, or S waves, they only travel through solids. And these surface waves are actually the slowest, but just because they're the slowest, they end up actually doing the most damage. So this image actually helps explain it pretty well. So you can see they have the different cars. You have the sports car at the top, that's going to represent the P wave. So the P wave is actually going to travel the fastest. And if you look at the diagram of the Earth, you can see that the green arrow is representing that it travels the fastest. So it's going to be felt first. And then we have the S wave that is the next one. So the next fastest, or second fastest. And lastly, the surface wave. So if you look at the last car, you can see it's kind of like represented as a, what are they called? Station wagon. You can see it's kind of fishtailing back and forth, and that's the reason why surface waves are the most destructive. So you can kind of think of that P wave as having a jolt of energy, but once that motion starts to happen, it's hard for the Earth's crust to slow down. And so you have that buildup of momentum that's occurring with the surface wave. Now, a lot of times people have the misunderstanding that tsunamis are not a weather-related incident. A lot of times people think that they're related to weather, meaning like flooding or rainstorm, but that's not the case. Tsunamis are actually formed due to earthquakes. So they're essentially deadly ocean waves from the sharp jolt of an undersea earthquake. So they're less frequently, these waves can be generated by other shocks in the ocean, for instance, like a meteorite impact. But fortunately, few of those undersea earthquakes and even fewer meteorite impacts generate tsunamis. Specifically, talking about their wave height, you can see the destruction. Tsunami waves have small wave heights, but they have long wave lengths. So they usually go unnoticed out in the ocean. And when traveling up a slope onto a shoreline, the wave is pushed upward. So as with like wind waves, the speed of the bottom of the wave is slowed by friction. This causes that wavelength to actually decrease and the wave to become unstable. So these factors end up creating an enormous and deadly wave. So it takes a couple of different scenarios for the tsunami to actually occur. So because of landslides and meteorite impacts and other jolts to ocean water that can actually form tsunamis, tsunamis can travel speeds up to 500 miles per hour, which is very fast. When we talk specifically about their wavelength, since the tsunamis are long wavelength waves, a long time can pass between the crest and trough. So remember we talked about how the crest is the highest point of a wave and the trough is the lowest point of the wave. Any part of the wave can actually make landfall first. So a lot of these end up occurring in Asia and near the Indian Ocean, those areas, because of where they have their plate boundaries. So a lot of times, for instance, in Japan, there was a large tsunami in the Indian Ocean that killed hundreds of thousands of people. And because of where it sits in the Pacific Ring of Fire, scientists are always trying to learn everything they can about predicting tsunamis because of how devastating the last one in Japan happened to be. So most places around the Indian Ocean didn't have warning systems up until 2005, and they do have them now, but these warning systems are being placed where tsunamis most readily happen. So you can also see in this diagram just how tall the wave height can actually be for a tsunami. So this gives you a good understanding that even a 2-story building, it's 2 meters short or 2 meters taller than the building. So this is an actual demonstration or an example of the wave height that one of the tsunamis that happened in the Indian Ocean in 2004, which was very devastating. All right, so guys, this is the rundown for earthquakes and tsunamis. If you have any questions, let me know.